Okay, we're talking about the graphs of y is equal to 2x minus 7 and y minus kx equals 7 are parallel when k equals what? If they tell you that they are parallel, we should know that the two slopes are equal. So let's find the slope of each of them. Y is equal to 2x minus 7. This is in slope-intercept form, y equals mx plus b, so the slope of this equation is equal to 2. In the second equation they give us, which has a k in it, we actually have to get it into slope-intercept form first, so let's go ahead and add our kx, which also could be thought of as mx. That would cancel. Putting my mx before my b would be kx plus 7. I actually didn't even need to do this because my slope has to be the same, so my m2 has to equal k, and I know that since m1 has to equal m2 because they are parallel, therefore k must equal 2. They have to have the same slopes. All right, let's look at the next section, which is 5-8. Graph absolute value functions, which we actually have already done a little bit of this as it is. Absolute value function has a V-shaped graph that opens up or down that we're going to work with this year. Later on down the road you can get V-shaped functions that are tilted or open right or left, but we will not do that in Algebra 1. Only the ones that open up or up and down. The standard form, or the parent function as they call it, for an absolute value function is y is equal to the absolute value of x. A translation is a shift of a graph horizontally, vertically, or both. The result is the same shape and size, but actually in a different position. Translation actually means to slide the object or the picture or the graph. So let's look at two different situations. First, I want to show you the parent function, y is equal to the absolute value of x. So if I get out a piece of graph paper and I were to graph this, understand this being the y-axis and this is the x-axis, the parent function is y equals the absolute value of x. So therefore, if I was to build a basic table, which is a good thing to start with for any type of equation, even the ones that you may have not seen before, and I substituted each one of those x's in, the absolute value of negative 2 is positive 2, the absolute value of negative 1 is positive 1, the absolute value of 0 is 0, the absolute value of positive 1 is 1, and so on, and the absolute value of 2 is 2. So if I was to graph that, I would plot those 5 points and notice where they form. Now, you have to be careful with absolute values because you need to understand that when it's absolute value, it's going to show a picture of a shape of a V. If you plot points and you don't see the V, that means you may have to build your table bigger, either bringing your domain smaller or your domain larger until you see where the turning point is of the V. So let's go ahead and plot the points. Negative 2, comma 2 would be right here. Negative 1, comma 1 is right here. 0, comma 0, I still don't see the turning point. 1, comma 1, there it is. Here's my V point. And 2, comma 2. This would go on forever, so make sure you go ahead and connect it with a line, arrowing it off in one direction to infinity. And there's my V. Then don't forget to go ahead and label it y is equal to the absolute value of x. This is a picture of the parent function, which again, don't forget the parent function is y is equal to the absolute value of x. Now what's going to happen is they're going to take this V and they're going to shift it. In math we call that translate it. They're going to slide it down, they're going to slide it up, and anytime you slide it or translate it up or down, you're adjusting it on the y-axis. Anytime you translate it left or right, you're adjusting or shifting it on the x-axis. So That's what we want to notice when we go ahead and see what happens to the equation as far as which way this v gets shifted. If you look at these two examples, example of, let me go ahead and actually, oh, I don't think I can do a slideshow on this. Nope, I can't, so we're going to have to deal with it. So if you look at this example of a vertical translation, the parent function, which they're showing over here on the left, which we just worked out, and then you look at, let me write this a little bit bigger, this one is y is equal to the absolute value of x. That's the one we just did. The second picture of an absolute value graph is y is equal to the absolute value of x. That's the parent function, and then they subtracted 2 on the outside. Notice that the minus 2 is on the outside of the absolute value bars, which really means that this minus 2 is going to affect the y-axis. Because it's minus, which makes perfectly good common sense, that it's going to affect the y-axis, which means it's going to be a vertical shift, translation, and it's going to go down 2 units. So if you look at where it originally started, which was right here, it went down 1, 2, and now the turning point is down here. So it got shifted down. That's what the equation looks like when you shift it down. If I was to shift this and make this a plus 2, then obviously the v would go up and it would be up here where it was a vertical translation up. The harder one to remember is the horizontal translation. This one's a little bit tricky. If you look at the first one, and I'm going to go ahead and redraw this sketch, but I'm doing identically what they have. I just want to walk us through it. If you look at the parent function, which would be this guy right here, and they give me a new equation, this is y is equal to the absolute value of x. If you look at y is equal to the absolute value of x, and then they add the 2 inside the absolute value bars, we now know that because it's next to the x, that 2 is going to shift on the x-axis, which means it's going to be a horizontal translation. Now, here's the tricky part because it goes against common sense. Anytime you do a horizontal movement, shift, translation, it's going to go opposite to what you would think. Because it says plus 2, it's not going to go 2 to the right, positive, which is what we would think. It's actually going to go 2 to the left, negative. So now the v gets shifted this way. And that one is y is equal to the absolute value of x plus 2. That doesn't make as much sense as the vertical, because vertical, if it says plus 2 on the outside, it goes up, minus 2 on the outside, it goes down. However, on a horizontal shift, it does the opposite. So let's look at this one over here. The equation they want me to graph is y is equal to the absolute value of x minus 2. Well, notice that the 2 is inside with the x, so we know it's going to be a horizontal translation, left or right. Because it says minus, and we're shifting horizontally, we actually have to do the opposite of what we think it would be. Minus makes me think of left, but actually horizontal is the opposite, so it's going to be shifted or translated to the right, like this. All right, let's look at that's the horizontal translation. I want to go ahead and show you guys, try one by yourself. So if you want to do it on graph paper, it would look nicer and it would be easier. But if you don't, you can do it on a sketch graph. I don't mind. So I'm going to set up a problem. Set up your XY axes. Don't forget this is your y-axis, this is your x-axis, and don't forget you guys have to label everything, otherwise you lose points on tests and quizzes. So if they ask me, I'm going to give you guys a little bit of a challenge, because I'm going to take x minus 2, which is a horizontal shift, and I'm going to add 3 on the outside. So I'm actually doing a double translation. I'm shifting horizontally and I'm shifting vertically. So go ahead and put me on pause, take a couple minutes, try to figure it out, and then see how you did on it. All right, first thing I want to remember, and I'm going to kind of give you guys the parent function. I'm going to do a dotted line parent function. Let's see. This is what the parent function looks like. You can see that okay. That's the y is equal to the absolute value of x. I did a dotted line because that's actually not what I'm graphing, but I'm thinking of that's how it starts. Then I'm going to go ahead and graph this absolute value function. Now, notice that it has a positive 3 on the outside. That means it's going to have a vertical shift because it's affecting the y-axis, and it does make sense because we go positive 3, which means we would go up 3. So that means I'm going to go 1, 2, 3. So right here. Now, the minus 2 tells me I'm going to take it, and I'm also going to shift it 2 units horizontally. Anytime you do a horizontal shift, it's going to be the opposite. So minus would make me think left, but really I'm going to move it 1, 2 to the right. So that means that my final graph will look like this after it has been shifted. And there it is. Y is equal to the absolute value of x minus 2 plus 3 is this top graph. It's been shifted up 3 and then to the right 2. Okay? Alrighty, very good.